Hi all, welcome to new class. Today's class is some problems related to determinants. That is, some problems related to the properties of determinants. So let us do the problems. First one is prove that determinant of a plus b plus c, 2a, 3a plus 2b, then 4a plus 3b plus 2c, 3a, 6a plus 3b, 10a plus 6b plus 3c equal to a cube. So here we have to find the determinant of this one. And if here we are determining the determinant directly, it will be very lengthier. So to make it easier, try to make any element 0. So for that, let us use some operations. That is, let us use the operation that is R2 implies R2 minus 2R1. That is, let us make this element and this element 0. So to make this element, we have this operation. R2 implies R2 minus 2 times R1. Then R3 implies R3 minus 3 times R1. So let us do this operation here. So here we will get this LHS is equal to, first row is same. So A plus B, then A plus B plus C. Then second row is R2 minus 2R1. So R2 minus 2R1 here 0. Then here we will get R2 minus 3A plus 2B minus 2R1 means 2A, then minus 2B. So here we will get A. So this is A. Then next element is 4A plus 3B plus 2C minus 2 times R1. That is 2A minus 2B minus 2C. So here we will get this 2C get cancelled. Then here 2A, then plus B, 2A plus B. So here determinant of. Then next row is R3 minus 3R1. So this one 0. Then next is 6A plus 3B, then minus 3R1. So 3A minus 3B. So here we will get, this is 3A. Then next one 10A plus 6B plus 3C minus 3 times R1 is 3A minus 3B minus 3C. So here also this 3C cancelled. Then 10A minus 3A is 7A. Then 6B minus 3B, that is plus 3B. Now again here we can simplify this one, that is this element we can make it 0 because this is A. So we can make it this element 0, that is R3 implies R3 minus 3R2. So here LHS we will get, first two rows are same. Then next one is 0, A, 2A plus B. Then here we will get R3, this one 0, this one 0. Then here 7A plus 3B minus 3 times R2. So 6A minus 3B. So this 3B get cancelled. Remaining is A. Now we can find the determinant of this one, that is delta is equal to, here we can expand along the first column because two elements are 0 here. So we can expand along the first column. So along the first column we can expand. So here we will get A into, remove that rows and columns. Then here we will get this A into A, that is, we can write it directly. So A square then minus this one 0. So that is equal to A cube. So hence it is proved. So in this way we can do the problems related to determinants. Next question is, without expanding, prove that delta, that is determinant of x plus y, y plus z, z plus x, z x y 1 1 1 equal to 0. So here look that here this is x plus y and in this row this is z. So we can add this one. Similarly here also y plus z and here x, then z plus x and here y. So we can do the operation like this. That is R1 implies R1 plus R2. So here we will get delta is equal to determinant of these two, we can add x plus y plus z. Here also we will get x plus y plus z. Here also x plus y plus z. Then z x y 1 1 1. Then here this x plus y plus z is common here, that we can take out. So here we will get x plus y plus z into 1 1 1 z x y 1 1 1. So by the property of determinants, here these two rows are equal. So or identical. So we can write that this is 0. So it is x plus y plus z into 0, that is equal to 0. Next problem is, evaluate determinant of 1a bc, 1b ca, 1 c ab. So here there is no common factors. Then let us do the normal row operations, that is, let us make this one 0. So R2 implies R2 minus R1 and R3 implies R3 minus R1. Then we will get first row is same, then delta is equal to 1a bc. Then second row becomes R2 minus R1. So this is 0. Then here we will get b minus a. Then here c a minus bc. That is, we can take the c outside. Then here we will get a minus b. So c into a minus b. Then here 0. Then c minus a. Then here we will get ab minus bc. That is, b we can take out. Then a minus c. So here b into a minus c. Then next here there is one b minus a and here also a minus b. Then here c minus a is there. Here also a minus c is there. That is negative of this one. This is also negative of this one. So we can take here b minus a outside and here c minus a outside. So here we can take b minus a from this row outside. Then c minus a from the third row. So from the second row b minus a take out. Then from the third row c minus a take out. So here we will get this first row is same 1a bc, then here 0, here 1, then here we will get minus c, then here 0 1 minus b. Now here we can find the determinant, that is b minus a into c minus a into, here we will get 1 into determinant of this one, that is expand along the first column. So here we will get 1 into this one, that is minus b minus of minus That is determinant of this one. Minus b minus of minus c. So here this one we can write minus of a minus b, then c minus a, then here this one we can write minus of b minus c, and that is equal to this minus minus get cancelled. So a minus b into b minus c into c minus a is the answer. Next question is, if x, y, z are different and delta is equal to determinant of x, x square, 1 plus x cube, y, y square, 1 plus y cube, z, z square, 1 plus z cube equal to 0, then show that 1 plus x, y, z is equal to 0. So here it is given that x, y, z are all different. Then let us find the determinant, that is x, y, z, x square, y square, z square, and here the third column is the sum of two terms. So we can express this determinant as the sum of two determinants. That is, using the property of determinants, we can express this determinant as the sum of two determinants. That is like this. We can split this one, that is 1, 1, 1, then plus again determinant of x, y, z, x square, y square, z square, then third column is x cube, y cube, z cube equal to 0. Then here this one we can exchange these two columns. So while exchanging two columns or rows, the sign will change. That is minus 1 into, it will become like this, x, y, z, 1, 1, 1, x square, y square, z square. Then again we can exchange these two columns. So again we have to multiply with negative 1. So the sign again changes. So here we will get 1, 1, 1, then x, y, z, x square, y square, z square, like this. So this one we can express like this. So minus 1 into minus 1 will become plus 1. So our aim is make the first column or first row 1. So here this is 1 here. So we can make this third column as the first column by exchanging the columns. So after exchanging the columns we will get like this, that is 1, 1, 1, then x, y, z, x square, y square, z square. So minus 1 into minus 1 we will get, it is plus. Then plus, and here from the first row we can take x outside, from the second row y outside, from the third row z outside, that is x, y, z take outside. So here we will get 1 x, x square, 1 y, y square, 1 z, z square equal to 0. Now here this determinant and this determinant are common. So we can take this determinant out, 1, 1, 1, x, y, z, then x square, y square, z square into, here we will get 1 plus, here the remaining one is x, y, z equal to 0. Now we can find the determinant of this one. So before that, this element and this element we can make 0 by the operations. R2 implies R2 minus R1 and R3 implies R3 minus R1. So here we will get 1 x, x square, then here 0, then y minus x, y square minus x square, then here 0, z minus x, z square minus x square. into 1 plus xyz is equal to 0. Then here this y square minus x square is y minus x into y plus x, and this z square minus x square is z minus x into z plus x. So here we can take y minus x outside, here z minus x outside. So taking y minus x out from R2 and z minus x from R3. Then here we will get y minus x into z minus x into 1x x square, then 0, here 1 y plus x, 0 1 z plus x into 1 plus xy z is equal to 0. Now we can find the determinant of this one, that is y minus x into z minus x into 1 into, that is expanding along the first column, we will get 1 into z plus x minus y minus x into 1 plus xyz is equal to 0. Then here we will get y minus x into z minus x into, here this x get cancelled, so z minus y into 1 plus xyz is equal to 0. And here in the question it is given that x, y, z all are different. So these terms cannot be 0 because these two are not equal. Here also z minus x is not equal to 0 because these two are not equal. Z minus y is not equal to 0 because these two are not equal. Then the only remaining term is this one. So this one will be equal to 0. That is 1 plus xyz is equal to 0. Because these three terms are not equal to 0. Only this term we can equate to 0. Hence, it is proved. So, that is about the problems related to determinants. So, let us do more problems related to this determinants, that is using the properties of determinants in the next classes. So, thank you for watching the class. If you like the classes, please like, share and subscribe my channel.